tapeworms that are 5, 6, 7 feet long. Like, yeah.
How do you get those?
The people back in the 1800s used to eat tapeworms as a weight loss plan.
Really?
Wait, do they have pictures of these things?
Oh yeah. Yeah, they're ridiculous. They're
5, 6, 7 feet long. And they're just inside your body.
in your intestines, yeah. Yeah, they're not a.
People still
Wait, did it work, the weight loss thing?
Oh, I'm sure it did. I would not recommend it by any means.
Doesn't it eat like the food that you eat?
It does. That's why you don't absorb the nutrients. Therefore, you would then lose some weight.
Is the tapeworm itself, like, without being in your body, like, that long?
No, they grow to that long because you have a constant supply of food that comes down about every 4 to 8 hours.
You could have, like, a foot-long tapeworm and you just, like, put a ball of ham in there.
Yeah.
Dang.
All right.
Wait, how is it bad for you then?
Because it's not part of your normal system, and it absorbs nutrients that you do need. So. Yeah, buddy. Yay! Right there. It'd be perfect. Thanks, babe.
Did we have homework on Friday?
No, we didn't have any homework on Friday. Yay. Okay. Okay. Let's take a look. At some point we had homework that was due at some point, so let's see if we have it. If you don't have it right away, just make sure you get it into me next time. What was it? What would have been the last page we would have done? What do you think? In the hundreds, right? 100 and something?
3 and 4.
103, 104, you think? What did I just hand back?
103, 104.
I handed back 103, 104? Okay. Yes. Heck yeah. So 103, 104 came back to you, right?
Yeah.
So we don't, thank you. We don't have one that would have been due on third. Oh, that's right, because didn't I kind of go on a tangent, talked about exact numbers of space flight?
Yeah.
Oh, yeah.
I remember that. Yeah, that was good old days. All right, so let's let me get some notes out to y'all for this. And wow. I'm so sorry. I was gonna dive for it, and then it would be totally awkward me diving across your desk. So what that teacher do? He was diving for some paper. Yeah. Sorry, I'm taking it away. That's really the best. You should see me at the mall. I'm horrible. All right. So let's go through these, and I want to give you the reason why we do this. In the world of math, prior to calculators, you all know that a fraction and division are the same thing. So they didn't want to have radicals in the denominator, or some sort of square root sign in the denominator, because it would have been really difficult to divide the square root of 3 into 1.000. So what they did is said, okay, we want to do something called rationalize the denominator, which means I'm going to multiply the top and the bottom by whatever the denominator is, or whatever I need to get a perfect square in the denominator. So I'm going to get that. If I multiply by that, that's the same thing as 1. That's a funny way of writing 1, isn't it? Here. Who got his ones? Well, I have root 3 over root 3. Okay. So if I multiply this, I go 1 times root 3 is root 3. And then root 3 times root 3 is then root 9. Do you agree with that? What's root 9?
3.
3. Okay? And I cannot reduce inside to outside of these. I can go inside to inside or outside to outside, but I can't mix inside outside. So then this becomes root 3 over 3, which is a nice exact answer, and it's a mathematically acceptable answer. Does that seem okay so far? And remember when we're talking about the perfect squares, and we'll keep writing down the perfect squares. I think Mr. Evans actually has a list of them up there up to 13, which is pretty cool. But let's take a look at this second one. So with what the knowledge I just gave you, what would you think you'd have to multiply both top and the bottom by in order not to have a denominator having a square root in it? What?
7.
Yeah, 7. Root 7 and root 7. So if I multiply 14 times root 7, I just get 14 root 7. There's nothing great about that. And the root 7 times root 7 is indeed root 49. And then root 49 is 7. Oh, and then there's one last step to this. Is the 14 outside on top? Is the 7 outside on bottom? Does 7 go into 14? Sure does. So this comes up to an answer of 2 square root 7. Nice exact answer. Seem good? Not quite enough for me to let you go on it, but I'll call it good so far. Ready? Here we go. All right. So again, let's see. Talk to me what you want to do on this one. Multiply top and bottom by what and what?
Root 2.
Yep. Root 2, root 2. So 4 times root 2 on top is 4 root 2. Root 2 times root 2 is root 4. Root 4 is 2. Can I reduce outside, outside? Yeah, 2's outside, 4's outside. So I wind up with an answer of 2 root 2. There's a nice exact answer. Now some of you might be saying, should I have it over 1? You can if you want. But 2 root 2 or 2 root 2 all over 1, same thing. Can I move on? Is there any questions so far about what we're doing? Is there a hand that I don't see? Okay, then you start getting to the ones where you're like, okay, there are sometimes perfect squares in there. But there are other things. You don't have a calculator out or your phone out that you can turn into a calculator? Is square root of 400 equal to 20? I don't know. Check on your calculator. Square root of 400 equal to 20. It is?
Yeah.
Yes? Agree? Okay. So square root of 400 is indeed equal to just 20. So what should I multiply both the top and bottom by that I can get rid of my entire radical? Can I multiply both top and bottom by root 2 and root 2? So that gives me on top 5 root 2. On bottom that gives me root 400. And you just told me root 400 was what? 20. And then 5 and 20 are both outside, so can I reduce those? Sure. Goes in there once, goes in there 4 times. So I get root 2 all over 4. Okay, let's take a look at that for a minute. Wait a minute. You know, I don't have to multiply both top and bottom by root 200 to get root 400,000 or 40,000? No. No, you don't. You can find the next perfect square that would work in the sequence. So a lot of times you might not realize 400 is perfect square because we only go out to 13 up here. Okay? But there is indeed 14 times 14, 15 times 15, 16 times 16, 17 times. So it goes on and on and on forever and ever. Okay? Can I move on? What do you think? Do I have something outside on bottom? I'm only worried about the inside. So what should we multiply the inside by to make that a perfect square?
3.
Yeah, root 3, good. So multiply top and bottom by root 3, root 3. So on top, I get 3 root 3. And on bottom, I get 2 root 9. What's root 9? 3. So I get 2 times 3, which is then 3 root 3. 2 times 3 is 6. Is the 3 and the 6 outside and outside? Yeah, so let's reduce it. 3 goes in itself once. 3 goes into 6 twice. So I wind up with root 3 over 2. Huh. I got a lot left. We good so far? Can I move on? You feel comfortable with this so far? Okay. What do you think? What do you think I should multiply both top and bottom by? Root 2 and root 2? I like it. Okay, so on top I get 2 root 2. On bottom I get 5 root 4 because root 2 times root 2. What is root 4? 2. So I get 5 times 2, which is 2 root 2 over 10. Is there anything outside that'll cancel? Yeah, 2 goes into itself once, goes in there 5 times, so I get root 2 over 5. I don't know, my division sign got lazy on me. One more page. That's it? That looks like it. All right. So, your homework is going to be number 4. So I guess that's page 105, 106. And you'll like something about 106 is it's blank. Okay?